In this video, you are going to learn about simple linear regression. Remember that whenever we make our code, we look at resources online in order to help us. Please visit these websites to see examples of some of the websites that we used and the code that we used in order to help make this video all that it could be. Before we get into our data, let's learn a little bit about simple linear regression and regression in general. So far, we learned using different inferential statistical models to compare groups. However, in many occasions, researchers aim to understand how different variables might affect language learning or test performance. To find out about the relationship between the predictor variables, or the independent variable, and the outcome variable, or the dependent variable, the outcome variables should be regressed on the predictor variable. The general term to refer to this statistical modeling is called regression analysis. The focus of the current lesson is on linear regression analysis. The linear regression can be simple, with one predictor variable, or multiple, with several predictor variables. A linear regression assesses the linear relationship between two, in the case of simple, or several, in the case of multiple regression, continuous, which can sometimes be nominal, variables to predict the value of a dependent variable based on the value of an independent variable. More specifically, it will let you determine whether the linear regression between these variables is statistically significant, determine how much of the variation in the dependent variable is explained by the independent variable, understand the direction and magnitude of any relationships, and predict values of the dependent variable based on different values of the independent variable. Now that we know a little bit about regression, let's talk about our data. Today, remember that these data are just for educational purposes and shouldn't inform your opinion about the subject matter. So our research question today is simple. Does the amount of time spent studying account for scores on a speaking test? And remember that we made these data up just for educational purposes. Okay, and I'm going to load some packages that we're going to use today. If you don't have these downloaded yet, make sure to install them. Then I'm going to grab my file, simple linear regression, and take a look at what's going on in the data frame. So we can see that we have case numbers, and here we have 100 cases even. We have study time and speaking score. So study time is in minutes, and speaking score would be assessed based on a rubric. Take a look at these assumptions, and these assumptions are going to be what guides the rest of the code in the video. First up, let's make a scatter plot. So with the scatter plot, we'd like to see a linear relationship between study time and speaking score. I'll run another piece of code, and we can see a linear relationship. However, what's going on here? We see that we do have an outlier, so we'd like to do some investigation about that outlier a little bit later. First, we're going to make our regression model so that we can run some more tests. So this is the data. This is the code in order to make a regression model. It's the equation of a line. It's a linear model. So I'll run that code. This is the summary of the regression model that we have right now, and it includes this outlier and a little bit more information about that regression model. We'll talk more about this output a little later. What I'm really interested in is this outlier test. And you can see we needed the regression model in order to run it. And we can see that this case is case 91 in our data frame. And let's go ahead and remove that outlier. And this is some code that we can use to remove the outlier. So we can see if we come, 91 is missing, which is what we wanted. So remember that this is what the scatter plot looks like with the outlier. Now we'll look at what the scatter plot looks like without the outlier. And you can see that the line has changed a little bit. This is the best fit line. So we'll repeat the regression model now without the outlier. Here in this regression model, we can see that study time is a significant predictor of speaking score. And down here, we can see our adjusted R-square, for example, F-statistic, and p-value, along with our degrees of freedom. After we get our regression model, we can take a look at our Durbin-Watson statistic. And here we can see that our Durbin-Watson statistic is approximately 2, which is what we're looking for. And now to check for homoscedasticity, we can plot our predicted values against the residual values, and this shows the type of association that we're looking for, so that's good. And next we can look at a histogram of our standardized residuals. We can see that it's approximately normally distributed. And we can look at a normality plot as well, and we can also see that this is approximately normally distributed.